In this lesson, we're going to multiply and divide rational expressions. So let's start off by simplifying these rational expressions. We're going to let a, b, and c, with the expressions that b can't be equal to 0 or c can't be equal to 0 because we can't divide by 0. So basically we're going to factor something out, and if it's on top, we can, and it's on the bottom, numerator and denominator, we can cancel it out because it equals 1. So there's just simplifies it. So for instance, if I were to take this first example of 15 divided by 65 and simplify it out to 3 times 5 over 13 times 5, we can cross out the 5's because 5 over 5 is just 1, and 1 times 3 over 13 is 3 over 13. And that would be a very simple integer example. If I'm dealing with polynomials, let's say I have on the numerator 4 times x plus 3 over x minus 5 times x plus 3. Well, these are like the 5's. I have two factors that are the same, both in the numerator and the denominator. These are polynomial or binomial factors, and I could just cancel them out, and leaving me with a simplified expression of 4 over x minus 5. So it's as simple as that for simplifying. Now, when multiplying, it's just like multiplying anything else. You just multiply the numerator with numerator, denominator with denominator, top with top, bottom with bottom, and you just mush it all together, if you were. So I'd have, for example, 5x squared times over 2xy squared and times 6xy cubed over 10y, and then I would multiply the 5 and the 6, which would give me 30, and x squared with x, which gives me x cubed, and then I just bring over the y cubed, and then do the same thing in the denominator. 2 times 10 is 20, x, just bring that over, y squared times y is y cubed. And because I can now simplify this. So basically I can reduce 3 over 20 to just 3 halves, because 10 goes into both. So I just cancel it that way, if you will, but it just reduces to 3 halves. And then I have 3 x's on top, 1 on the bottom, so I can cancel out 1 from both top and the bottom, the numerator and denominator. So I'll be just left with 2. And then since I have a y cubed both in the numerator and denominator, they both would cancel out completely. So I'd be left with 3 halves x squared. And that would be multiplied and simplified. So let's look at a little bit more complex example. Okay, so here I have two rational functions I'm multiplying together, and what I would want to do here first is factor these instead of multiply first, because like if you look at the numerator, I have a binomial with a trinomial, and I believe I'm going to get, if I multiply them together, I'll end up with a quartic polynomial, and those are just a big pain. As you remember, we had to come up with a list of rational functions and do a bunch of synthetic division, and really I just don't want to go there. So it'd be much easier to factor everything first and then multiply. So let's do that. So the first thing, look for GCF. I can pull out a 5 and an x, which would leave me with 4 minus x. And in that denominator, I'm going to pull out an x. So I factor out an x, leaving me with an x minus 1. Over here, I have let's see, a trinomial, which I believe can be factored to x minus 1, x plus 4. And then the denominator is a difference of squares, so that's just going to be x plus 4 times x minus 4. Now, one of the weird things I have here is I have this 4 minus x, and I'm leading with the 4 and not the x, but the x is negative. So I want this to be look like all the other binomials. So the way we can handle this is we can factor out a negative 1, which would change all the signs. So I can rewrite this as 5x times negative 1, and now this becomes negative 4 and positive x. So I'll just flip them around, and then I'll just kind of bring everything else down like so. And let's see, x minus 1, x plus 4, and then our difference of squares, oops, and x minus 4. Okay, so now when I multiply it, I'll just say, hey, that's going to be 5x, and you can multiply the negative 1 with the 5x instead of keeping it separate. It doesn't really matter. I'll go ahead and do it and deal with it accordingly. So now I'm going to have x minus 4, x minus 1, x plus 4. And again, concerning that negative 5x, you could have also initially pulled out a negative 5x. Just sometimes we don't always see that right away, and then we could compensate by factoring out the negative 1 later, but either way, it doesn't matter. And now we're going to multiply everything in the denominator together. So let's see, it's going to give me x minus 1 times x plus 4. And see, because we've factored it ahead of time, it now becomes really easy to just start canceling stuff out. So I would just look at what I have in common. So for instance, the x's up front here, those are individual factors, so those can be canceled. This x minus 1 and this x minus 1 cancel out. This x minus 4 and this x minus 4. And wow, we have two x plus 4s which cancel out as well. And really, when you multiply these together and simplify it, you're just left with negative 5. So that equals negative 5. That's it. That's all it's to it when everything is said and done. So everything kind of just took itself out except for that. So that's multiplying. Let's look at a different type of multiplying. Let's say we're going to multiply a rational with a polynomial. This is largely the same thing. There really there's not a huge difference between these two, other than when we write this out, it's just like if I had it's kind of like if I were to say, hey, what's 1/2 times 3? Well, we'd write that as 3 over 1, okay? But this time we're doing it with a polynomial. We're going to say, oh, it's going to be times x squared minus 2x plus 4. Guess what? Over 1. Same principle applies. And then we're going to want to factor these as best we can. So let's see. This is nothing we can do in the numerator, but the denominator is a sum of cubes. So hopefully you remember how to do that. So let me rewrite this. So x minus 4. And that's where we're going to have our a plus b, where this is a perfect cube. 8 is 2. and then a squared, so x squared, and minus ab 2x, and then plus b squared, which is 4. And remember, I knew the signs because of SOAP. Same, opposite, always positive. It's that whole SOAP thing. So if you don't remember that, go back in your notes and look that up. Now, when I do this top one, I want to be careful because it looks like it might factor. It looks like it might be a perfect square trinomial, but it's not, because this would be minus 4x in the middle, because it's 2ab. And if you look closely, oh, it's the same thing as we have down here. So this is not factorable. So I'm just going to bring this down as is. Common mistake would be to write that as x minus 2 squared, and that's just not the case. Now I'll multiply these together. X minus 4 times x squared, x squared, minus 2x plus 4 over x plus 2 over x squared. It just does not want me to write a squared. Minus 2x plus 4. And I look at what I have in common, and it's these two trinomials, and they cancel out. So therefore, I'll be left with the x minus 4 over x plus 2. Does not want me to write 2's. Computer's being a bit slow, so it doesn't keep up with the writing. But anyway, there you have it. And so that's multiplying a rational with a polynomial. Now let's look at the next operation, which is going to be division. And dividing is just about as easy as multiplication. You just take something as simple as 2/5 divided by 7/3. You just flip one of them, in this case the second one, and then multiply straight across. So flip and multiply. Generically, a over b divided by c over d is equal to a over b times d over c, and multiply. And we would do the same thing in this case when we're dealing with rationals. So I'd flip this, I'd flip the second rational, so the 2x minus 3 that was in the denominator is now in the numerator, and then multiplying together. In this case, there's nothing to simplify, so you would leave it like that. So you can flip and you can multiply, you're good. Oh, and you do have to know how to factor. But at this stage of the game, I'm all the confidence in the world that you can do it without a problem. So let's do this. We're going to divide these two. Now you can either flip it first, then factor, or factor, then flip. I'm going to go ahead and flip it first. So we'll say x squared minus 4x minus 21 over 5x plus 15 times, and as I'm flipping this, yes, you can cross multiply if you're going to divide. That would be acceptable if that's how you prefer to do it. By all means, have at it. And I totally forgot to flip. Okay, so I went ahead and fixed that. Now let's factor these. So this top one should factor to x minus 7 times x plus 3. And the denominator factors to 5. This is the only GCF we can pull out, so that's going to be x plus 3. And we have a difference of squares, so I have x plus 10 times x minus 10. And then down here I'm going to have x plus 10 times x minus 7. Oops. Okay, that's supposed to be a 7 with the parentheses, but my computer's messing up again. Alright, so actually before I multiply, let's make this a little bit easier so we don't have to write as much. We can just start canceling some things from the get-go. So the plus 3's cancel and the plus 10's cancel here. And since I know that I'm going to be canceling out, I'm going to multiply these together, I could just go ahead and cancel out the 7's, because I know when I multiply, I'll have an x minus 7 on top and an x minus 7 on the denominator. So I'll simply be left with, after my multiplication, x minus 10 over 5. And that's it. As they say, piece of pie. Because I like pie more than I like cake. But that's just me. Anyway, that's how you multiply and divide rational expressions. So until next time, I'll see you on the flip side.